Assalamualaikum and greetings. In this video, we're going to talk about the condensation of aldehyde and ketone. This reaction is quite unique because it can be found in the reaction for aldehyde and ketone only. Let's start off with the reactant for this reaction. Of course, the main compound will be aldehyde or ketone. The next reactant that we need to have is the nitrogen atom, which attach at least two hydrogen. This can be compounds such as ammonia, hydrazine, or any of the hydrazine derivative such as hydroxyamine or 2,4-D-NPH, which stands for 2,4-dinitrophenylhydrazine. For every nitrogen atom, it attaches at least two hydrogen. Let's take an aromatic aldehyde such as Benzaldehyde. And we're going to react it with ammonia, which is NH3. The ammonia can also be written as NH2, which attached to hydrogen. The condensation reaction will occur between the H2 from the nitrogen, which is going to react with the oxygen from the carbonyl group, which later on going to produce water. And the product that we are looking for is benzene attached to the C double bond and then attached to H, and then we're going to attach the rest of the structure of the nitrogen to the double bond. So it will be looking like this. The side product of water is the result from the condensation reaction between these two compounds. Let's take a look at another example. This time around we're going to use ketone. We're going to use pentanthreone as the carbonyl compound, and we're going to react it with a hydrazine compound. Hydrazine is NH2, NH2. Since both sides is the same, we're going to choose only one side. Let's use the first NH2 as the reaction side. So what's going to happen is the H2 will react with the oxygen to produce water. The double bond will remain, and we're going to attach the rest of the structure towards the C double bond, which will become NH2. That's why for this reaction, at least we need to have a nitrogen which attach to the two hydrogen, so that these two hydrogen can form the water molecules. Moving on to the next example. Let's say we're going to use aldehyde. In this case, we'll be using pentanal, which reacted with hydroxyamine. Again, take note that this reaction will occur at the nitrogen atom, which have two hydrogen attached to it, because later on the H2 will combine with the oxygen to form water molecules plus the product of the condensation, which is N attached to the OH. Again, we're going to take the two hydrogen from the nitrogen and replace the position of the oxygen from the carbonyl group. Finally, we're going to take a look at the reaction between a carbonyl compound with 2,4-D-NPH. The usage of 2,4-D-NPH is also known as the Brady's test reagent. For instance, if we have acetophenone as our reactant, and we're going to react it with 2,4-D NPH. We're going to perform the same process whereby the H2 will react with the oxygen to produce water molecules. And the product that we are looking for is benzene attached to the double bond, attached to the CH3. We're going to add the rest of the structure N attached to NH, attached to the benzene ring, which have the nitro compound. So there you have it. This is the condensation of aldehyde and ketone. In summary, there are two things which is required for the reaction. The first one is a carbonyl group. Doesn't matter it is aldehyde and ketone. The second one will be the nitrogen atom, which at least attached to two hydrogen atom. Because we're going to take the two hydrogen atom and then we're going to react with the oxygen to form a water molecule. And the C double bond will retain the structure regardless whether it's aldehyde and ketone. Later on will be attaching to the nitrogen atom. That's it for the condensation reaction. See you guys in the next video. Goodbye.